Number 9. At equilibrium, which of the following must be true in a buffer solution? At equilibrium. So let's go through the various options. A, the mole ratio of weak acid conjugate base must be 1:1. So when we're looking at mole ratio, we're looking at the amount of conjugate base, which would be here, and weak acid, which would be here. It's not necessary that these are in a 1:1 ratio in order for this buffer to work. If they're not in a 1:1 ratio, it will change the pH of the buffer, but it won't keep the buffer from being in equilibrium. So they do not need to be 1:1. The pH must equal 7. Again, buffers can exist at all different pHs. As you saw in your lab, you could have buffers at a pH of 4 or buffers at a pH of 11. It just depends on the ratio of acid to base that you put into your buffer, or specifically which acid and which base pair that you use, and that depends on its Ka value. The rate of dissociation must be balanced by an equal rate of reassociation. This is what it means to be at equilibrium. Every molecule that dissociates into our ions must be countered by an association into its molecule form. So C is the answer. The mass of weak acid must equal the mass of conjugate base. The masses are irrelevant once you're in moles. It really just depends on the molecules. And one acid could weigh a lot more than the base, but it doesn't keep it from donating a proton. So the mass is not relevant. So C is the answer.